The 420 milliamp signal is telling the pressure switch, when to kick on, when to kick off. Entrance to the wet well is right where Adam's standing over there. If you can find Rick's flashlight, Adam, I can show him what it looks like in there. If you can pop a lid on that, you get some idea.
Right behind you here.
That's where we go monthly to maintain the wet well, which is basically clean it. Hose it down, bust up the stuff and clean it. Yeah. The wet well goes from, I don't see the door frame there, from the door frame to the outside wall, straight down is the wet well. The other side is the dry side, hence the wet side, dry side. Once Adam pops that lid, you can get an idea what the wet well looks like. That's why they make those round too, so you don't drop through the hole. By cleaning it monthly, keep down on the issue. People, if they don't smell it, they won't know it's a pump station. Chances are this guy built his house and wound up wonder why there's a pump station in front of him because he never looked ahead of time and said it was a pump station. And that's what happens. They put pump stations according to how they project out 15 to 20 years of expanded growth in this area. If they got the money to put a pump station in, run it at like quarter the speed so the area builds up. Well, the pump station's been away before the houses come in, then they bring the houses in, and then the houses complain that there's a sewer line. Just like, you build your house next to the airport and complain about the things. Really great.
Another generator here. Power that.
Okay, this station has backup generator power, just like the other one is designed to run the station at full load for 24 hours.
24 hours, this thing
Yeah.
will run full bore?
Yeah, this will run the station, with the station calling for a full demand for 24 hours. Everything's automatic, has an automatic transfer switch. Basically, it senses the power phase or fail off, turns it on and switches power over to the generator. We'll switch back after it senses the power has come back. We also get alarms when this happens. We come in and check to make sure everything's working. Nothing is ever faultless. If it's switching out a pump that's running, it might fail that pump. Not just a breaker problem. And that's due to old age and just how it's sensitive, how the switch made. Usually the switch is pretty fast. Blink of an eye. Boom, it's done.
Now, is this all
That's
acoustic tile, basically?
Yeah. They set these things up for, I think there's a 2-hour maximum limit or whatever's on the door, 3 hours on the door. Running. All wet wells like this right here are vented. Everything has to be vented to keep the gases out. When this generator comes on, automatic fans come on. Go to the right side.
That's not station.
Ops challenge practice is their the Olympics. What do they call that thing? Ops challenge.
Ah, there you go.
This is part of their jump, so they designed a store here. This is the motor control center for the station. The station has 3 pumps. I don't know, they're 40 horsepower, I believe. Marathon pumps. I think I gave you all the breakdown on them. Pumps are controlled the same as the other station with a bubbler system, pressure system, which is, this tells you the level of the wet well. Okay. This is maintained with the air compressor system, which goes up. This is the one that tells the 4020 milliamp signal that tells these pressure switches what the level is in the wet well. That's basically the same. It has a backup float system to go with the pressure system. This is an antique station by the Relays. I think they made this when they launched the Mercury spaceships back in the 50s. The pump goes on in 3 stages. So it feeds amperage to the pump at 3 different stages. This way you don't have a big draw on the station and you don't destroy the motor on the pump, or torque out the drive lines and stuff. This traces going 3 drive lines, I explained to you. So it'll come on in 3 stages, boom, 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 and then it should be a full power, full amperes. That's the old system. There's 3 big transformers and 3 big switches in here, switch gear and a big transformer on the bottom. What happened a while back is the transformer caught fire and burned out the whole bucket. So we went and decided to update it to the newer stuff, which was this. Basically, it's a a VFD soft start, but it's not a VFD. I can ramp this soft start to do different things how I want it to start. So you got this big panel. If I can open it up, I'll show you. I'm not going to do that. This is switchgear from here to here. It's solid wires and metal. This has a box about this big that does the same thing that those things do. This is what we're updating to. That's your incoming voltage, 3 phases, and it also gives you, when the pumps are running, it'll give you amp readings for each pump. Like I say, this is like the old 1950s stuff over
works.
here.
It works.
It's gonna break the wheel.
Houston?
New item we put in, this PLC is like basically a glorified timer. It tells what pump to come on when. Or it knows what if a pump has failed, it'll tell the pressure switches not to call for that certain pump. If you have a question on your test, are our drive lines, like in this situation, are they lined up dead even with each other? Or are they all canter by so many degrees? And if they are, why?
How many degrees off are they? 45?
You never set these things up directly in line. You give about a 1 to 2% offset. This way it keeps the vibration down from blowing out the whole system.
Isn't it 1 to 2? 1
I
to 2
think
degrees?
it's 1 to 2.
They're not belt driven though then, right?
No.
Okay, then why is it?
Yeah. It's all mechanically driven from the motor. This is an airbag. Airbag valve I told you about, the other station. This is sitting on top of the force main. The force main runs and discharges this out.
And then who's the offset?
Down here, 1986 build.
Put it this way, the station, the station on flat, this pumps out 2 to 3 million gallons a day. This one is lucky if you do 1.5 million. But this is like switch gathering.
Hey, Anthony,
Yeah,
what kind of valves are these, the big wide bodies? They look like barrels or something.
those are plug valves. Plug valves, that's the ones I told you about earlier. They have a sheet that comes over and closes the valve and just plugs it off.
Oh, okay.
It's relatively square inside that valve. But this is your standard setup for a dry side in the old school way with dry line pumps and centrifugal pumps. You got your suction, where the arrow says towards the pump, that's the suction side. Yep. And it's neck down to 90 that goes up to the eye of the centrifugal pump and discharges out the side. It discharges to, I think it's 16-inch or 18-inch force main that's up on top. Check valves are big old-fashioned plate pneumatic check valves that are on the planet. Dry side is the same.
Dry side,
It's not
besides the wet
typical
side.
for a wet side. But that results in really square. Look at the pneumatics. These pumps have mechanical seals.
Mechanical seals.
They need to be water. Water has to be supplied to the mechanical seal. Else it just destroys the seal, and then you have sewer leakage coming up here. So that's what we have a water line hooked up on the pump. Every time the water's on, every time the pump's on, it tells the seal to open up the water valve and it's metered into the seal to keep everything lubricated. Without the seal, then you're looking at $1,200 seal when you're not destroying it.
It doesn't actually get on until it gets to a certain level, right?
Yeah, it's pressure.
That's why they're dry right here right now.
Whereas those submersible pumps we saw at Clackamas, they have a coolant lubricant already in the jacket. They don't require any water for the seal. It does it all itself.
We saw those at the garage.
Yeah, it's on there too.
You might want to get straight out, fix out. I'll do that.
That's just the way it is. Well, it's easy to T-sections, you're not supposed to have T-sections. The short 90s they got with the suction on these pumps is bad. Right? They got another short 90 around 45 right there is bad. The reduction is bad. The whole thing is, in my opinion, needs to be done hydraulically and more efficient on the pump station. No, it's what they had. I think when they built this, they had like so much of this on the shelf or when the fluctuation changes, it starts spitting out this. And when you're doing your backflow checking, you can't get an accurate reading because it's moving all the time. This is the choice where you do that bypass. You take that from there and fill it back here, and it'll give you at least a stabilized enough you can get a picture of what it's doing at the time.
I'm gonna have to check that one.
But backflow, in my opinion, these are the best ones with the individual exposed checks.
Pull 'em out.
Inline stuff, they should just get rid of that
Yeah,
completely.
especially even for repair, you just pull it right out and whoop.
This one, you can see it, you know what you're getting into. Well, all the stations have backflow.